because of this like change in plans, today we are going to talk about rapid programming language that I briefly discussed in the previous class. So today what we are going to do is basically start doing something similar to what we have done previously, but this time we are going to do it using rapid programming language. So let me see, where are the files that I left for you here last night? So I remember I put some files here last night for you. Maybe I haven't published it. Let me just stop sharing for a sec and go to here. Yes, it's here. Yeah, thanks to super handy and understandable interface of ITAR. Again, I published something, but I forgot to publish the parent folder, so you couldn't see it. So we are going to download this file, which is a small file, not that big. Let me share again. Good. So you just need to download this Robot Studio Station. So if you go to your Canvas, Files, and you have a new folder called Rapid. And in Rapid, you can download this RSPAG file, which is basically the Robot Studio package. And I save it using the method that I mentioned about sharing and packaging the file. And it opens as a, some sort of like zipped folder with all the files that you need to have. And when you click on it, it's going to automatically open in Robot Studio without any problem. So that's the thing we are going to discuss today. So let me just close this window. I also left one PDF file here, which is called ITAR Rapid Handbook. And it's basically a quick guide to rapid programming language and the material that we are going to cover today. So you can also download this one, put it next to yourself so you can actually have a look. I suggest to keep it somewhere around yourself wherever you're doing rapid, because basically rapid it's not the most convenient programming language, and the number of people who are working with it is not that great. Like, for example, if you have millions of people, like, I don't know, maybe tens of people working with Python, you can barely find maybe 100,000 people working with Rapid. So the online documentation may not be that great, but anyway, we have this document that covers all the necessities and things that you need to work with. So there are some discussion about the syntax, the keywords, semicolons, or whatever style. And if you're familiar with any other programming language, this logic is the same. It just only has its own syntax. Okay, so as always, when we are opening a package, it's going to ask us a couple of questions. It's asking us where do you want to open it? When do you want to, which version of Robot Studio you want to use? And we are just going to go with the formalities and say yes, 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 continue, because hopefully it's not going to make any problem with any of your computers. I think I'm opening it with Robot Studio 2020, which is good. And you can also open it with 2019 and 20, because I saved this file last night with 2019. So it's forward compatible. Let's see. It's going to take a while. So first, I'm going to show you what's happening in this file, and then I'm going to explain how to do it. What are we doing in this file, and what's the purpose of every part of it? Okay, before we get into this part, how many of you have any experience with any programming language? Ila, do you have experience with programming languages?
I did Python and Java.
Okay.
Python, Java, and C language.
Okay. What about the rest of the class? Emilio, do you have any experience with programming? Okay, you will learn.
I don't.
Yeah.
I have very limited experience with Python and processing.
Okay, so good. So we have different range of programming skills. And so I'm trying to keep the pace with the whole class. I'm not going to jump crazily to anything. So let's see what's happening in this file. As you can see, we have a tiny 120 robot, like this big robot. And then we have a gripper, which is made by ABB. It has the branding on it with 2 shiny dots on it. And this is something that ABB makes and delivers with the Yumi robot. Just Google the Yumi robot. It's so cute. And we can install it on the robot, and it works pretty nicely. So let's see what's happening in this file. So I'll go to simulation and I hit play. And here's a fun fact, you can also play from here. I haven't noticed this here, but anyway, when you hit play, it's going to work and it's exactly doing what it shouldn't do. So basically it should go down, grab this object, and then comes back. I need to change something here. So let me just make sure that I'm doing the correct thing. So, I need to, there's one thing here. Okay, digital outputs. I want to make sure that the creeper is open. Okay, now let's see if it's working. Yep. So this creeper goes down, it goes down, and hopefully it grabs that object the way we want it. Yep. Good, it actually closes the creeper, it grabs the object, and then it moves it around. Okay, it moves it around, put it in the correct place that it should go. So, from this process, I want somebody to actually raise its hand and tell me which parts of this we know how to do and which parts are the parts that we don't know how to do. Emilio, do you want to tell us like which parts that we have already covered in the class and which part is the one that we have not covered yet?
We haven't covered like moved it to a side or.
Exactly. We covered everything except the fact it's physically grabbing the object.
Yeah.
And it's pretty simple and straightforward. So basically what we are going to do is to quickly explain how this happened, how this like magic of gripping happened. But there's something very more important in this class today, and that's something happens in this rapid panel when we go to this part. So what we are going to discuss today is how to program a robot using this programming language instead of just using those physical interfaces and visual interfaces. So if I want to explain exactly what's happening on that file, I can make a vertical tab like this. So I just right click here and I have like one. And then I can make a new vertical tab if I don't have. So vertical tabs means it's going to put two tabs next to each other. And from my logic, it's actually two side-by-side horizontal, but I don't know. They call it a vertical tab. And let's see what's happening here. So basically, when I run this robot, you can see what's happening. So first, imagine that I want to run this robot from this program. And this is something that you should always do. You should always right-click here and set the program pointer to routine. I'll explain it later on, but mainly whenever you're doing the job, do this at the beginning. And then, when you hit play, this is going to make the robot run the workflow. I need to reset it in the file. You have this reset switch to make sure that this box is coming back to this position. But when I hit play, I want you to look at the robot and also have a look at what's happening here, okay? And I will explain later on what's exactly happening. So I hit play, and you can see that there are two signs here. Something happened here. The program stopped. Do I need to push the robot to its original position? Yes. Give me a second. Maybe I pressed something. Okay, this is cool. Let's go grab that program pointer. Hopefully this time it's going to work. Come on, did I just kill something on this robot? Okay, the robot is enabled. Now I hit this one. Okay, so I need to do some extra stuff. Okay, because I reset everything at the middle of this. That's what you get at that moment. Okay, so let's see. So somehow I just killed this robot. Did I? Interesting. So let me just reset the robot. I somehow messed with the whole operating system of this robot. So I'm going to warm restart it. Because Robot Studio tries to mimic the whole system with these robotic workflow, it also does the job of simulating its safety system. So sometimes we see these problems. So hopefully this time it's going to do its job. So I hit play. You see that the robot goes down. You see that it goes down, but I forgot to detach that tool from it. But it goes on, and whenever you're looking here, you will see that there's a sign here that shows the robot, and also there is an arrow that moves ahead of the robot sign. Can you see these two signs here? Okay, so here's the point. Whenever I'm running this code or I'm running this robot, basically Robot Studio and the robotware, which is the operating system of the robot, are going to run this code line by line, and it's going to show you at each moment where the body of the robot is right now doing and where's the logic of robot is taking care of everything. So if I run this code again, you will see that sometimes these two signs are moving next to each other, which means that the robot tries to run a motion command. And also its computer is running something similar. But sometimes if you look carefully, you will see that this robot is actually doing something different. Like at some moment you see that when I'm doing this like repair, open and close, or I'm using wait time or something, that pointer moves ahead of the body of the robot. And this is something you're going to see a lot in this workflow. But basically remember, whenever we are doing something with this robot and we ask the robot to do it, it's basically trying to read this program and run it line by line. And this is the main logic. And today we are going to understand how does it work. But in order to get there, let me just start with this presentation. So let me figure out how is it going to work on this keyboard of mine. Okay, so basically that piece that you saw earlier is a programming language that's called Rapid. And the Rapid is the language that's only being used on these ABB robots. And it's working with any version of ABB robot that we have, like all the 3 robots that, actually all the 4 robots that we have, or any similar IRB family robot that you can find anywhere on this planet are going to work, hopefully, with this Rapid language. There was one other language before this Rapid, but right now it's just replaced that one, and it's one language to rule them all. And it's a really high-level procedural programming language, and it's developed and maintained by ABB to program these ABB robots. Bunch of jargons here, like very high-level procedural programming language. What does that mean? So basically, when I say it's very high-level language, means it's using pretty similar wordings compared to what human beings are talking about. Like if I get back to that file that we had here, you see that it has some commands that are basically easy to read and we can understand. For example, it says wait time. It doesn't say 01010101, which is impossible for us to understand. So whatever we do in this programming language is pretty similar to what we do when we want to communicate as human beings. And that's really helpful for us because it makes it easier to understand. This is the same fashion with other, programming languages that are embedded in some other softwares like running a script and MEL for Maya. And it helps us to understand the workflow, do the job quickly, but it has some trade-offs that's not, the matter of fact, interesting or important for us. For example, we know that these high-level languages are significantly slower than low-level languages like C++ or CUDA. But that's none of our business. We're not going to bother ourselves with that one. And then there's one important thing here that's called, it's a procedural programming language, which means that it's using a series of well-structured steps and procedures. Do you remember that robot sign and the arrow sign that was moving like one by one in a specific order? So that's the part that is important for us when you're talking about ABB, Rapid as a procedural language. And we can actually predict and control this process of happening. And this is really important for us to figure out what's the flow on that side. But let's see how a Rapid program works. So basically, if I want to explain how this whole system works, it's something like this. Imagine that you write a program for your robot. That's what Robot Studio and Rapid called a task. and I will show you where you can find these tasks. And then inside the task, we have a bunch of modules that each module is like a notebook that has a bunch of stuff inside of it. So think about a task as a briefcase that holds a bunch of notebooks, and inside each notebooks you have different chapters. And you may ask yourself, like, why do we need to do this? And why do we need to have such a complex structure of something that's not going to help us that much? Actually, it's going to help us a lot if you want to do something pretty complex. But generally speaking, for this class, we are using not so crazy complex workflows, and we only have one task, and inside that task we may have a one module, barely two modules. I've never seen any project in ITAR with two modules, but we may have multiple procedures and function and routines. So this is important to understand how this hierarchy works, but a simple programming rapid program would look like this. And as you can see, it just basically says that, okay, this is the module and this is a procedure. And if you remember, this main thing is happening at the middle. And if you want to see where is that structure that I discussed in the code, it's actually here. If you look at a rapid code on the rapid panel, you will see that on the side, there is something called rapid here. And then underneath it, we have this T_rob1 or rob1. Basically, that's a task that has some modules underneath it. You see that it's program module and system module. Good news, never touch a system module and don't get bothered with that one. We only work with the program modules. And inside the module, we have different procedures. And as you can see, procedures are something we have used before. Basically, those paths that we were making, each of them is actually a procedure. And main is something that each code must have, because when Robot Studio or Robotware runs a task, it always looks at the module and finds main and only runs whatever is located inside main. So this is a quick overview. So if you want to get back to our file, you can see that when we open our robot in Robot Studio and go to Rapid panel, we will see that for each controller, we will have this rapid structure that has a task inside of it. And inside that task, we have a bunch of modules. And inside that module, we may have one or more procedures. So this is the hierarchy. Actually, if we use, for example, Machina, we may have two tasks that are running in parallel. And that's called multitasking. And this is the only case in which we would use multitask. But setting up the multitask and other stuff is going to happen automatically, and you're not going to get bothered with that part. The whole point is we are going to make a module, and then inside that module, we are going to do whatever we want to do. So that's the important part. Okay, so let's get back to the presentation and discuss a little bit more about this whole Robot Studio thing. So where are we? Okay, here, about this rapid thing. In Rapid, we have data, and data is basically a location in the memory with a name, because we want to refer it later on. And it's holding some sort of a quantity or information for us, and we call that one value. So let's have a look at our code and see what's happening here. So this is the code that actually I generated for you. So if you open that file, this is going to be there, and you will see it from the beginning. But let me actually delete this one, or in better way, I can actually comment them out. So they're not going to bother anybody, but I'm just going to move them down so it's not going to interrupt with our workflow. So if you actually look at the rapid code, let me bring up some rapid code that I have previously, so something easier to figure out, like this one that we had here. So basically, a rapid code can be as simple as this. Okay. Oh, that was a bad mistake. Let me just. So it's basically a rapid code, and it's right now it's its simplest way possible. As you can see here, it starts with something called a keyword. And keywords are in through the studio blue, dark blue, which means that this word is being saved and preserved by this programming language, and it can only be used at this capacity to define the beginning of a module. So this is a mandatory part. For any type of code that you write in Rapid language in this class, you need to start with this sentence, module, and then say something after it. So module means that we are going to define a module, and inside that module that's named, like, for example, in this case, main module, we can call it anything else. We can call it like ITAR module. In any case, it should have a name that doesn't have any space bar at the middle. It should not start with a number. And it doesn't matter if you go lowercase or uppercase. It doesn't make any difference for Rapid programming language because it believes that uppercase and lowercase are the same. So when you make this, basically you say that I have a module that's called ITAR mode, and everything that's inside this module is the work that I'm going to do. And then there is something really important about the way this interface works. Whenever you change something in this code, you need to hit apply. And as soon as you hit apply, it's going to actually show up here. You see that this name has changed from whatever it was into ITAR mode, and it only shows this procedure that I have here. Okay, so inside each code, we have at the beginning a place to play with our variables. Variables, as I mentioned, are pieces of memory of your computer that have a name, and they can hold a value for us. So this is, it's a variable that's going to be a number, and the name is len. And this is the format that we are going to see a lot. We say what it is, we say what's the format, and we tell it what's the number. And by this way, we are technically declaring a variable. Declaring variable means that we are going to assign a piece of memory and say that, hey, computer, would you please hold this piece of memory for me and just don't put anything inside of it for now. I just want to have this piece of memory, but later on I will get back and use it. So it's really important for us to have these pieces of memory assigned for us. For those of you who have experience with Python, in Python, you just basically say, for example, wherever you want, whenever you want, you will say that, yeah, for example, data equals 10 or whatever. That's not the way Rapid works. In Rapid, like in some other languages, for example, like C# or C++, you need to define your variable or declare it earlier in order to use it later. And for Rapid, keep it in mind, it's really important. You should do this at the beginning. You cannot do it somewhere here. Like if you try to make this sentence here, you will see this red line underneath that variable, and it says unexpected data declaration. So basically, it doesn't expect you to declare a piece of data or play with it after you start doing your operations. So variables are piece of memory, values are piece of memory, variable type of value that has a name, and it can be defined by you. And there is one other procedure about these values, and it's called initiation. Initiation, yes, correct. Which means that you're not only declaring the variable, you also assign a value to it. And this is crazy. In Robot Studio, when you want to assign a value to, in Rapid, when you want to assign a value to something, you just don't simply put equal in front of it. If you put equal, it's going to say, nope. You need to put this colon and then equal to let it know that, yes, I want to have this value being stored in a variable that's called width. So this is really important about variables. You make sure that they are defined before any operation. I will get to that later on again. And you need to use that crazy syntax to assign something, colon equal. If you don't do that, it's going to give you an angry, red line and says, nope, it's not going to work. And you have already noticed that I did something tricky here. I put an exclamation mark at the beginning of one line. And then when I did that, the whole line became green. And this is our magic key to convert a line into a comment. So if you're familiar with any other programming language, you know that when you make a comment in a line, it means that the computer or the compiler is not going to even look at that line. It assumes that this is something for your eyes only, and it's for humans. So the computer is going to just skip that line, but it's going to run the line after it. So whenever you want to write a code, I strongly recommend you to put enough comments everywhere that you find necessary, but don't overkill. Basically, overkill in comments is not a good idea, but no comment is the worst thing ever that can happen to your colleagues if you're working somewhere else and your future self. For example, you write a code today, you close it, you go for, I don't know, spring break, fall break, a coffee with friends, and you come back and you will realize that, I have no idea what this code is doing. So always leave enough comments. There would be a balance between these blue and black lines and these green lines. So make sure there's a good balance over there so you can understand. Okay, so variables and values are basically these pieces of memory. So just to go ahead.
So basically, what I'm seeing here is that you're able to, like, you have to define the variable within the main sort of module, but you can, you name the variable in the module, but you can define it with a value within the procedure. Is that possible?
Yes. So let's go a little bit more accurate. So this is the main procedure. So we can have more procedures, just to clarify. So let's say that Erdogan procedure, okay? And inside of that, do nothing, okay? Let's have a bigger view here. Okay, so from here, from line 1 to line 20, we have the module, okay? Anywhere before the first procedure, you can declare and you can initiate every type of value that you want. And we will get later on into different types of values. You can do whatever you want before the first procedure. As soon as you go for the first procedure, you cannot define anything after that. And also, inside each procedure, you can define a variable again. Okay, and you can also not only declaring them, you can also initiate them. Do you see that there is no red line underneath it? But if I just simply put that line here, you'll see that I'll get a red line that says it's an unexpected data declaration. So if you want to declare a piece of data or initiate it at the same time, it should happen at the beginning of that level. So if you are in the level of module, you should define your variable, declare your variables, and maybe initiate them before getting to your first procedure. If you are inside a procedure, you can do it before you get into any of these statements that are doing something like operations. So this is the key rule, like never put a declaration after any of these statements that assign something or calculate something or move the robot. So this is the general rule. Is that clear?
That's clear. Thank you.
Okay, good. And,
what's the difference between variables that's been declared like inside of main and like outside of main?
Oh, that's a question, that's a math question. So basically, if you define something here in the higher level, everything below it can see it. If you define something in the lower level, for example, inside this procedure, only
like local.
Yes, it's going to be local to that one. So if you're familiar with the concept of local and global, that's fine. But for those of you who are not familiar, I'm going to explain it later on. So yeah, and that's going to make a lot of headaches, to be honest, if you're not comfortable with these local and global variables. Okay, so far we understood there are variables which are a kind of value, but we also have different kinds of value. Like we have persistence, we have we have persistent and constants that are slightly different. They are not variable. So whenever we are working with our codes, we are going to have a bunch of variables, a bunch of values, and we are going to work with them constantly. We have already seen them, actually. If I get back to this piece of code that I wrote here, all these tool data that we had, all these targets that we made, they are also pieces of values, but they are in different types and format. There are two keywords here that I want to bring up and we can discuss about them. So there is this thing that's called persistent, and there is this other one that's called constant. So all of these variables, persistent and constants, are values. Okay, it means that they are all a piece of data in the memory of computer that have name. The point is, variables are something that you can change later on. Persistents are, let's first go for constant. Constants are the one that you cannot change. For example, if you have a variable and it's the variable value is, for example, equal to 0, later on you can actually change that 0 into 5. No problem. But a constant cannot be changed. Like if I try to, for example, change this rope target start point to something else, probability is going to give me some error that said, nope, it's a constant. I'm not going to touch it. You should never touch it. And sometimes it's really good. For example, it's something, if there is something that you never want to change, for example, the voltage that should go, for example, to this device, you always set that one as a constant because you don't want to change that voltage to burn that device. But sometimes we have something called persistent, which means that it is like a variable. The only difference is that once you change its value and reset your code, that value is going to change. And this is really interesting. So let me do something cool here. So I'm going to make a persistent, and I'm going to say it as a number. And for example, it's going to be a number, and it's going to say like pers sample. And I'm going to make it equal to 0. And then somewhere in my code, I'm going to change it. Pers sample equals to 10. Did I make a mistake here? Let's see. Oh, I made an, okay, type. Good. Just look what's happening here. This number, it's still a value, so it's a piece of memory that can be assigned to something. And I define it as 0. I also have this one as 0. Okay, just let me bring it down here so you can see what's happening. And then I'm changing this width into 5, and I'm changing this persistent sample into 10. I'm just going to put it next to each other to make sure you can see it clearly. When I run this code, what's that error? And errors in the rapid program. Okay. Let's see what's that error that we have here. Oh yeah, these two lines should be. Okay. Let's see what will happen when I'm running this code. When I hit apply and when I hit play, oh, still give me an error. What is that? Did I change something that I should? Oh, yes, here. How come I missed that one? Okay. Apply and play. Really? I'm getting all these errors. Now, no problem. Okay. So I'm running this piece of code, and let's see if it's doing the job that it should. Interestingly, it doesn't do the job completely. Did you see what happened here? So I first set this number to 0, and I also set this one to 0. And then later on, I change it to 10. When I run the code, you will realize that this number automatically changed into 10. So a persistent piece of value is basically remembers what value it was holding the last time we ran the code. And this is really critical and important. For example, imagine that you run a code, and in that code, you ask the robot to change its tool, and you want to remember what tool was installed on the robot the last time. And this is the thing that we use. We use persistent to make sure that, for example, we still know which tool is connected to the robot. Or, for example, how many pieces of material we have used, or how much progress we had in the workflow, or if the safety system is on and off. So this is the type of data that we are going to use a lot in our workflow, and it's really helpful. So basically, these are some of the important properties of data that we are talking about. So this is really helpful to understand what's going on in this code. But I can go through this whole slide deck and explain like different parts of this, but I realize that sometimes it's easier to, instead of going through this whole workflow of explaining every piece of this code, I prefer to actually explain how to write the code quickly and easily. My suggestion is, after this class, you have 1 week to go through this document and read it. And then in the next lab session, we are going to have more advanced programming. But my suggestion is, for now, is to follow me and see how we can program the robot to do that Reaper thing using this rapid programming language. So I'll leave these, that handbook, the PDF file, plus these slides on the canvas. And during the next week, when we are actually doing hands-on with robots, I strongly suggest you to read this whole document and get familiar with this syntax and ideas. For those of you who have no background in computer programming, you should actually read it carefully, especially that handbook. And then when we get back the week after to continue working on this rapid, you will have a better understanding of what's going on. So I'm going to leave this slideshow here, and then I will focus on what's happening here. And I'm going to start from what we left in this file. Okay, so let's see what we have in this file at the beginning. So if you look carefully, I have something simple here. So if you are opening the same file, I think everything should look like this, except that the fact you may not have this panel here. In order to get this panel here, you should go to simulation, and you should go to IO simulator. And if I hit that one, this is going to show up. And it may actually show something irrelevant. You need to go here and show your digital outputs. And once you're there, make sure that you have this gripper open. And once you did that, just start from home, okay? If you do so, make sure that this gripper activates. And if the robot is here, this thing is here. Okay, is everybody in the same boat? Everything is the same? Good. So let's see what we have here. We have a pick point. And if I go here and select the view robot at the target, you see that, oh, this is the pick point. This is the pick safe, which is unusually in the wrong place. We have the place point, and we have the place safe, and we have the starting point. To be honest, from these 5 targets, we don't need these 2. We can actually delete them. We are going to make them later on. So this is what we have, okay? A robot, a gripper, and 3 targets, okay? Now we want to start from here and write the rapid code to let this robot grab those objects. Okay, so as I mentioned earlier, whatever you have here in this 3D environment, which is called this station, is completely separated from what you have in your rapid programming environment. So I have a lot of stuff here, but when I go to my rapid code, you see that there are different stuff here. So they're not related to each other at this moment. In order to tie these things together and sync them together, so whatever we have here showing up in the rapid code, you need to use this tool called Synchronize. Don't click on it yet. There's a catch. So if you just click on the top part of this Synchronize switch, it's going to just jump into synchronizing from station to rapid. But if you click at the bottom part of it, it gives you the option to bring everything from the station to the rapid code or bringing everything from the rapid code to the station. So for now, what we want to do is to actually go and synchronize to rapid. But before that, I want to actually clean up my code to make sure that there's nothing extra and unnecessary here. So I'm going to delete everything that I have. And even these lines here can be deleted. And I think that's a good idea to keep everything clean. So this is what your rapid should look like. Now we go here to our station. And then we say synchronize to rapid. Okay, when we synchronize to rapid, this menu pops up. And if you look carefully here, you see that there are different options about what you want to synchronize into rapid code. And this is really important to know what you have changed and what you want to bring from your station to the rapid code. In this case, to be honest, we want to bring everything, so we can just click here and keep everything that we want. And we know that some of these things are actually not existing on our file. So for example, we don't have any work object, but we have a tool. We can actually uncheck this one, but it doesn't make any difference. But at the very same time, it's going to ask you a serious question. Where do you want to sync everything? I can select whatever module that I have in my system. And by default, it's going to make everything in a module called module 1. But if you remember, a few minutes ago, I made an ITAR module.
Sorry, for my software that the synchronized part is gray. I can't click on
It's
it.
great. Okay, maybe you haven't selected any of these controllers. So you should make sure that you have selected this one. Have you selected that?
Yes.
Okay, is your controller working? Like this is green?
Yes, but still gray.
Interesting. Can you share your screen for a sec?
Yeah. I'm gonna share my screen.
Good. So, let me just first let you share your screen. Okay, stop sharing this one. Then going to these advanced sharing option, all participants can share. Go ahead here. So your synchronization is off. You're in modeling view. Okay, so, okay. Can you just expand this, panel at the bottom?
This one?
Yes. No. Let me just also connect with my iPad.
Yes.
So I can write something. Yeah. So yeah, that part that you're, okay, now it's my
It's
mouse.
below.
So let's see. Schedule. No. Okay, so can you expand this part? Yeah, just move it up. So we don't have any error here, so that's fine. Let's see what's the possible reason for that one. Make sure that you're also turning off this one. And once you did that, can you just, can you go to simulation and make sure it's off? Yeah. Okay, that one is also off. It's really odd that you don't have that part. Let me think about it for a second. Is there any way I can actually control your mouse?
I don't think you.
Yeah, no, it's not possible. Huh, that's something I haven't seen before.
Actually, I remember at the beginning when you open the file, it just the box this is also under the.
Yes, can you go and reset this one? Like there's this reset here. Yeah. Yes. That's not me. Something is fishy here. Some part of your code is different. So can you go to home again? Yep.
So how about just
I think close it and open it again. I'm not sure exactly what's happening here.
So
just exit and open it again.
open
Like
it.
close the whole Robot Studio because it needs to turn off your virtual controller. So that virtual controller is not the most reliable thing ever, but just turn it off, like close the whole Robot Studio and see. Okay, we are here. Okay. But for example, there was one difference between your file and mine is that you didn't have these options at the bottom.
Oh, it's different. Yeah.
That was something a little bit unusual. So let's open that file and see what's happening. So for the rest of the class, you have this synchronization option.
Um,
Can you hear me, everyone?
yes, I can hear you.
Can you go through again like how you have that like module on the right side of the screen?
Oh, this one?
Yeah.
So basically, I went to simulation and I just hit that I/O simulator. And when you hit that one, this window shows up. And inside that, you need to make sure that you're selecting the digital outputs. And it's really important because by default, I think it's on device and it's slightly different. So digital, not input outputs is the one that you want to go for. Okay. So that's the one we should go for. And then we should go home and synchronize to Rapid and make sure that you're selecting, for example, ITAR module that you made, or you can also go for module 1. It's your personal preference. But remember, they are all going to be there. So if I hit OK, you can see that there's a message here that says everything is synchronized to Rapid and it's completed right now. Okay, so if I go to Rapid, you will see that, oh, it's actually making that stupid mistake. You see that things are here, but not all of them. You see that there's only this tool data here. Your main procedure is empty, and there is no target or anything associated with it here. So here's the catch. Whenever you want to bring something from your station to your Rapid code, it needs to be inside a procedure, which means that you basically need to have a path. And inside that path, you can synchronize these targets to your Rapid code. So basically what I did was pretty simple. I just basically grabbed these 3 targets, add them to a path, and now I can right-click here and use this synchronize to Rapid option. And it was also here. I can also access it by right-clicking here. So 2 ways to do this. Either go here, hit synchronize to Rapid, or right-click here and use this one. And it's again going to ask you, where do you want to put it? I would say in the same place that I had the previous ones. And then I will hit, make sure that everything is in the same place. And I will hit OK. Okay, now it's done. And right now, if you look carefully, you will see that we have our main procedure, we have our path number 10, and we have 4 pieces of data here. Okay, so if you have the same setup here, we can continue working. Is this the same for everyone? Go ahead.
I have 4. Yeah, I do have 4 variables like on the top, but my main isn't empty. It has things.
Yeah, it has something
there.
from the previous code that we have. Am I right?
Okay. Yeah.
So if you haven't deleted that one, it may have something inside of it. So go ahead and delete it. And right now we have the data that we want to start with. And we have some commands that we may use or may not use in our procedure. Okay, so we have this Rapid code here and we have this station here. So I'm going to use that vertical tab group. So I will have these 2 views here. So basically, if you set up like this, you will have your code on one side and you have your robot on the other side, so you can have a look. Let's see what do we have here in this code. Basically, we have our values. And basically, it's also data. Okay. And as you can see, the first one is our tool. And these 3 ones are actually our targets. You remember, like previously, our data was very simple, like this number. And it was, for example, equal to 0. But these are very more complex values. So these are simple values. These are like complex values. And basically, if you look carefully, it holds all the data about the tool that we have. And we will get into the details of these values later on, but basically it holds the value about if this tool is connected to the robot, where is the TCP of this tool, where is the center of gravity, what's the weight of this tool, and everything in that capacity. And you remember that previously we used to do this all the time. For example, we would say, where is the Z value for the TCP, what's the weight of that tool, what's the center of gravity, blah, 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 blah. Don't worry about it. In many cases, we are doing them automatically. We don't need to enter them manually. But what is important and interesting for us is the data here, the targets that we are working with. So here you see that we have a peak point, and then we have a bunch of numbers after it. What are these numbers and how we can use them? So basically, these numbers are in a specific order, and they define where is the target, what is its orientation, what's the configuration of the robot at that point, and if we have an external axis, what's the status of that external axis. The reason that these look really awkward is the fact that these three numbers are basically X, Y, and Z value that we are familiar with. Like we can completely understand this is a point that 500 millimeters in front of the robot. It's not left, it's not right, it's exactly in front of it, and it's 30 millimeters above the ground. The catchy part is this one. These four numbers are defining the orientation of the tool. But we usually are familiar with this Euler system that says rotate around X, rotate around Y, and rotate around Z. But that has a lot of problems when it comes to 3D reorientations. So Robot Studio uses a system that's called quaternions. And in quaternions, you define the rotation of an object using four numbers. And these four numbers are interconnected, so you cannot change one of them manually at will. If you change one of these numbers without changing the other three, it is going to get really, really mad about it, and it's going to throw error because these four numbers have special connections to each other, so they should be calculated in respect to each other. So that's something we usually do not touch. But just by default, know that 0010 means that it's facing off. And these four numbers are defining the configuration of the robot. This is something that we don't touch. We leave it to the robot controller to decide about, or Robot Studio to decide about. And these six numbers at the end are the numbers that are related to the external axis. For example, if you want to move that 6640 robot on the track, we should put 4700 here. But since this robot doesn't have any external number, external axis, we don't touch these numbers. So basically from all these scary numbers here, the only ones that we touch are these three. So don't get worried about all these numbers here. We usually define the Euler rotation and then let the Robot Studio calculate this part for us. We usually use this one, define this one using auto configuration, and we never touch these things for these small robots. So basically, don't get confused by all these numbers. Just remember, the first set of numbers are X, Y, Z of the target. And if you look carefully, you see that these peak place numbers are pretty similar to each other. So if I just move this one a little bit more, you will see that from this point and on, everything is the same. We just change the X, Y, and Z of these three targets in order to get these 3 points. Starting point, which is here, up here, start point. Peak point, which is here, and the place point, which is here. Now we can basically make a path that goes through these three. I'm just going to delete these lines because we are not going to use them. Imagine that you want to start doing this code and do something with it. And I'm going to first writing it in plain human language. So this is what I'm going to do. I'm going to ask the robot to go to a start point. And then I'm going to ask the robot to go to peak point. And then I'm going to ask the robot to go to place point. So first, I draw the outline of the action in plain human language. And then now I want to actually make this as a rapid code. And as I mentioned, rapid code is a high-level language, which means that it's pretty understandable for a human being. So we remember that when we wanted to go to the starting point from wherever we are, we usually use move J command, which is basically moving the joints of the robot. So if I just simply type move J, you can see that this environment, which is the IDE of Robot Studio, automatically suggests you the command that you should use. And it also shows you some hints about what you can do at this moment. Like, for example, move J, and then what should follow it, this one. So if you want to even get more comfortable with this whole workflow, if you double tap on your tab switch on your keyboard, so I'm going to hit tab twice, it's actually populating the whole command for you. So you just need to place some extra data on it. So I just basically typed move J and then double hit tab, and it makes this whole line for me. And as you can see, it says it's move J, so I'm going to delete this one because it's redundant. It says move J, then it needs some sort of argument, which is basically the target that you want to reach out to. And then it asks about the speed, it asks about the zone, it asks you what tool do you want to use, and then it's going to finally ask you what work object you want to use. So if you look at the text that we wrote here, the note that says we want to ask the robot to go to the starting point. So move J to a starting point. So I'm going to say delete this part, and let's go to a start point. And you see that as soon as I type start, it brings up the start point. You can either click on it, double click on it, or you can, I think, hit enter to complete the text. And 1000 is actually super fast. You don't want to go that fast. So let's go with 100. And Z50 is fine. And if you want to use this gripper fancy tool, so I'm going to use the tool called Servo, which is the name of this one by default in Robot Studio. So this way, I ask the robot to move from wherever it's located right now into the starting point. Now let's go and see how we can do the same thing with the peak point. For the peak point, we still move with move J. And the only thing that we need to change is to go to peak point. So I'm going to delete this part and say, oops, I deleted too much.
I have a question.
Go ahead.
What happens if you place a velocity that it's above the possible for the machine? It like breaks?
I think it's going to cap it. It's going to cap it with the capacity of the robot. And if you run the robot in safe mode, basically running it in manual mode, it has a hard cap around 250 millimeters. So it's going to reduce the speed to 250 millimeters. And to be honest, in like 95% of the time, we just run these robots on the manual mode, and the robot will never exceed that speed. In order to get to the full speed of the robot, which is different for each robot that we have, you need to actually physically bring a switch, like a key, and unlock that power, and then make sure that everybody is leaving the room and all the safety systems are on. Then we can run the robot on the speeds of, for example, 1000 for the big robots. But I think for this small one, we cannot go beyond 500 or something like that. So if the speed is too much, it's basically going to be capped automatically. Okay, now it's your time to finish the last line. So what would be the last line? Does anybody want to make a suggestion? Molly, do you want to suggest what we should do here? What's the command that we want to add here? Molly, can you hear me?
Sorry, I lost my mouse for a little bit.
Sure, don't worry. So do you want to suggest what should we do here?
Do you want to convert like the movement to move L?
Exactly. It's move L because it's the fine target that we want to go for. And what we should put as the argument here. What's your suggestion?
Is it a place point? Or actually,
Yeah, that's place point.
mhm.
You're correct. And you actually caught my error also because I used move J here. I needed to have move L here. Okay. And your suggestion is to keep the speed and Z value the same, or do you want to update them?
Go slower. And so,
Yes, I think it's a good idea to move it slower because that's the place that we are going to do something serious. And what about Z?
should we put it to 0?
Yeah, we can go for 0, which means that the robot is going to do the most accurate thing it can do. But we can also go for fine, which means that the robot goes there, make a hiccup, and then comes back. And thank you very much. You're exactly correct on all of them. And the point is I can update this one also. Okay, it's pretty good. Like we have the thing that we wanted to have. So basically right now, if I run this code, it basically starts from here, goes to pick, and goes to the placing. And this seems like a good starting point. But is this what we were looking for? Like, is this the real thing that we are doing all the time? To be honest, it's not the case. If you remember carefully from the last week, you know that we always have a couple of extra points somewhere at the middle, something like this. We usually, let me just zoom in and move around. We usually do something like this. We usually define this target here, but before that we have something on top of it. We go here, we go down, we come back, we go here, then we go down, we come back, and then we go up. Okay, we usually do this because we want to make this workflow, but we are missing this and this, which are the safe place and safe pick. These are the things that we need to make right now. And one question is like, why don't we make them just in this station? And why do we bother ourselves making them here? Because for educational purposes, we want to see how we can do this here. And also in many cases, you actually bring these data, like the point that you want to pick from a real robot. Literally, you go to the lab, you move the robot to the pick place, you save that target, and then come back to this Robot Studio thing to edit everything. So imagine that we have these files from the real lab and we want to edit them. So what we want to do here is to actually grab this target and then move it for like, I don't know, 25 millimeters up. Okay, so I want to grab this target that I know that this is the peak point, and I want to move it up for 25 millimeters. And then ask the robot to do the job for us. There are easy ways and there are hard ways to do this. So let's do the easy way. So I would say that, okay, I have this peak point here and I have everything about it. I know what's its X, what is its Y, and what is its Z. I can simply change this number into something new and that's going to solve my problem. I can say that, okay, this is the peak point. What if I just change its name? I just copy pasted that one. I just change its name into pick save. And I just added 25 to 30, which results in 55. And now I have a target that's exactly in the same X and Y of the pick save, but it is 35 millimeters above it. Problem solved. And I can do the same thing with the place. I just grab this one. I make sure that I have changed the name and I manually add this number and convert it into 55. And I hit apply. Problem solved. Now I have a target that's 35 millimeters above this one and it does the job for me. But have you noticed that we don't see it here? Like, can anybody tell me why don't we see it here? Is there anything wrong? What can possibly go wrong?
We have to synchronize it?
Yes, exactly. It's just like grasshopper thing. We need to synchronize it back into the station. So I will go here, synchronize to station, and then Robot Studio asks me again, like, what do you want to sync? And I'm like, sorry, I haven't defined this one. I need to use these targets in order to do so. So I'll go here. It's actually there. I need to use it in a sentence so I can actually use it. So let's add these two lines of code to get to these safe points. It's going to be pretty similar to what we have done with this, for example, move J for going to start point. So I'm going to say that let's move J to the peak safe. And yeah, we can go slightly slower. And we also get back from that peak safe in a linear motion. So again, I go to the peak safe, peak, come back to peak safe, and then I can go. Okay. We should do the same thing with the placing. So I will copy paste this part. So it should be place safe. And again, I'm going to copy paste this one. Place safe. And I carefully inspect everything to make sure that the syntax is correct. I'm not putting peaks and place in the wrong order. The benefit of naming everything carefully like this is the fact that you can quickly look and say, okay, all the peaks are here, all the places are here, and the start is separate. Once I'm done with these parts, I can hit apply. And I look here, down here, I realize that, oh, there's no error. Everything is like blue and white, so no problem. And now I can synchronize to the station. Right now, if I hit this one, you can see that it has all these targets for me. So let's go for peak safe and place safe, which are the two targets that I just made. Hit OK, and they immediately show up here. It seems pretty cool. Right now, we have our targets in the correct place. They are safe. Maybe I should have made a little bit more of clearance, but let's see. Okay, so this is so far a good starting point. We have these points defined, and we can do whatever we want to do with them. But to be honest, it is not the most elegant way of solving this problem. Right now, we did something that's called hard coding. Basically, we grab these targets, which are coming from Robot Studio, and manually added a value. As I mentioned a couple of seconds ago, I realized that this distance is not enough. I needed to increase this number, and make sure that it's slightly higher, because I think this 25 millimeter is shorter than these fingers. And when the robot arrives at this target, the fingers are already touching the tool. And I want to raise this number into something like maybe 65, or maybe 75, or maybe 70, best case. But it means that every time I want to do this, I need to do it manually in each pieces of my code, which is really bad idea. Right now, it's only two numbers. But what if I change something and I need to change it like 20 times in my code? So my suggestion is that instead of manually changing these numbers, we should find a computational method to solve this problem. So I'm going to define this. And why do I have an error here? Yep. I'm going to do something a little bit different. I'm going to make this peak safe, initiate it, declaring it, but I'm not going to set a value for it. I'm doing it again with this place safe. And I will keep these two here and here. Okay, here's the point. By default, Robot Studio syncs target as constants. But when you make a constant, it means that throughout your code, you cannot change the value of that piece. I want to make a target that I want to define its value later on. And it's really important to make sure it's a variable, not a constant. So I make this one as a variable from the type robot target, and it's called peak safe, which is different from this structure, which is constant robot target peak point. So I'll go with this structure. because later on I want to change it. And it doesn't matter if I go lowercase or uppercase, it doesn't make that much of a difference. So now we have this pick point and this place point. And I have these two targets that are not actually holding any value at this moment. So let's see what we can do. I want to have these 2 points, pick safe, to be exactly equal to this pick point, but slightly higher. So this is what I'm going to do. I'm going to come here. I'm going to say that I want to have my pick safe to be equal to this pick point. Okay. But I want to have this position on the z value to be equal to pick points position x plus maybe 45, maybe 40. Oh, this is getting crazy. What happened here? What is this thing that I'm doing? Go ahead.
Shouldn't that be Z trans D?
Oh, yes, sure. So let me explain what happened here. So in these two lines, I did something pretty quick and pretty fast. I said, I want my pick safe to be equal to pick point, which means that I'm going to have my pick safe exactly at this place. So right now, both pick point and pick place are exactly the same place. No problem. But I'm asking Robot Studio to change something in my pick safe. So basically, I will ask Robot Studio by putting this dot here to access every single piece of data that we have inside this target. So pick point is a target for the robot that has transformation, and it has rotation, it has configuration, and it also has external access. So by this syntax, I would say, Robot Studio, please look at this pick safe and go to its translation, which is like these three numbers. And from those three numbers, please pick the Z value, hold it in your hand, then select the same Z value from the pick point, add 40 millimeters to that one, and then update my pick safe Z value. So basically, it's going to read the Z value of the point, pick point, add 40 millimeters on top of it, and then update my pick safe Z value with that one. So if the Z value was, I don't know, like it was 30 at the beginning, now I'm going to add 40 to that 30. So it's going to put the target somewhere here, which is 70. Okay, so this is the way we can access the internal values of each target. And this is really important because now we have some good methods to update these values and plays with them without being confined to the definition at the beginning of our code. Right now, this 40 is serving the job I'm asking for. And I can do the same thing with the place safe. So place safe is going to be equal to place point. The only difference is that I want to have this place safe transformation Z value equal to place point dot trans dot Z plus 40. Okay, so we have these two targets and it seems pretty handy. And then you will ask me, Ardavan, you add that 40 again twice. What's the difference of adding it here and adding it here manually? The beauty of coding is here. I can actually save this 40 as a different variable. So I can say that, okay, I want to have a variable which is type of number and call it safety distance. and put it equal to 40. So I can copy paste this instead of these 40s. And every time I change this number, like into 30, maybe 40, or even 60, this number is going to be updated. So when I'm running this code, whatever I change here is going to be the value that defines the distance between my targets and their safe targets. So this is a more elegant way of using scripting and like these programming approaches into solving such a nice and simple problem. So now we have our peak place, peak safe and place safe, and we can use them easily to get to that point. So I'm going to apply this code. I'm going to clean this part. And now let's run this code and see what happens. The robot goes down, and you can see that these lines are trying to catch up with each other. So the robot moves up, it gets the placing point, and it goes down and doing the job. You may ask yourself like, something is fishy here. We still have these two targets in the same place. The reason is that we have these pick safe and place safe in our station. So we need to delete them. So we are not going to see them anymore. Now when I'm playing the code, it's going to be pretty simple. If the code moves so fast and you cannot catch up with it and see what's going on, I can run this code step by step by clicking on this. So it's going to run this code one line at a time. So right now I'm just defining these targets. And now I'm going to make the first move J command. So let's see, the robot goes there. Awesome. Then I go for the next step, which is that comment line. So next step, the robot goes down. Then the robot goes all the way to pick up the object, does the job for us, and comes back. And from here, the rest is just like whatever it used to be. So you can see that it's doing the job. It's pretty nice, pretty clean and understandable for us. Okay, so let's see what else we need to do. Do you remember when we were doing this like pick and place, we used to have, let's say, these wait commands and then set the gripper and other stuff? That's what we are going to do here. So let's see what we should do. So we know that when we get to this safe place, we need to go down, and then here we should make a wait for a sec, and then we need to close the gripper, and then we need to wait for a sec again to make sure that the gripper is closed, and then we can walk back. And again, when we are placing the object, we need to wait for a sec, and then we need to open the gripper, and then we need to wait for another second. So these are the things that we usually do. Like we get there, we wait for a second to make sure that the robot is in its place, then open the gripper or close it, whatever is the case at that moment, and then wait for a second to make sure that the gripper is closed, and then we come back. And then for sure, whenever we are doing this like a move to a start point, we make sure that open the gripper to make sure that at the beginning of the workflow, the gripper is actually open. Okay, so this is a file that I set earlier, so it has some of the things that you should do previously in advance. But basically, let's follow the logic here. First of all, it wants us to open the gripper. And you remember when we wanted to do such things, we would just go here, right-click, insert action, and then here we would say like set DO and select this DO that we wanted. Actually, we are going to do the same thing, just in plain, typing. So here I would say the command was set DO. And if I go here, you see that we have a lot of sets, but let's go for a set DO. And if I double click on that one, it's going to make this argument for us. So it says set DO, what is the DO you want to change, and what number do you want to change it into? So I want to change the gripper activate. So if I just write GR, it's going to suggest me this gripper activate. And since I want to open it, I hit 1. And you can see that by 1, it opens the gripper. And this is something that we were looking for. So right now, if you run this code, you will realize that it's going to open the gripper for us. So let's do this. First, we need to apply, make sure it's applied, and then let's start. You see that at the beginning, it does that job, and make sure that the gripper is open. And if you want to see, you see that this value become 1, and that's an indicator that this gripper is getting open. Okay, let's the robot finish this part. Yeah, so let's go to this part and see what we can do here. And it's really important. Whenever you want to do something with this robot, first write it in plain human language. In more advanced one, we are going to talk about making a flow chart to get more familiar with this workflow. But first write it as human language, then try to replace it with the computer or the robot language. So as I wrote here, I want to wait for a second. So I will write wait. And there are lots of wait systems, like waiting for a digital input, wait for a digital output, wait for time that is the one that we want to have. Again, if I double click and double tap on tab, it's going to give me the options and autocomplete everything. So I'm going to wait for 1 second. And then I want to close the gripper. So I can use the set DO again. And it's going to automatically populate gripper activate. And this time I want to close the gripper, and somehow it knows it should convert it into 0. That's odd. And then I want to wait for another second. Okay, seems like a plan. It's doing the job. It seems the way it should be. So we have all these commands, and we can repeat the same thing for here. I can say that wait time for another second here. And to open the gripper, we can go ahead and say set DO, gripper activate, and I'm setting that one to 1 because I want to open the gripper. And then I would wait for another second to make sure the gripper is open. So this is how my code look like. A little bit fuzzy, a little bit like not exactly the cleanest code ever, but it does the job. It first updates the targets. Then it does some basic commands like getting to the original point and then opening the gripper. Then it goes for a pickup, and then it goes for a place. Seems like a plan. So let's apply this one, and now it's the time to run it. So keep an eye on this gripper activate thing, because that's something that changes in this code. And let's have a look at what's happening here. So let's play the code. So the robot goes up, goes down, cross our fingers, it goes down all the way, closes the gripper, which is awesome, grabs the object, this is also awesome, and gets to that place that it wants to finish the job, opens the gripper, and leaves it there. And this is how it works. Pretty cool. It's the way we wanted it to work, and I'm pretty impressed with the workflow. Okay, so this seems like a finished code. Seems like it's doing the job we were asking for. It seems that it's exactly what we wanted to do, and it seems like a solution. Yes, it is doing the thing that we were asking for, but it's not completed. We need to do some cleaning and organizing and making sure that this thing is on par with the standards of programming that we have, and it's also readable for the people who want to use it later on. So far, any question? Anybody has any question about anything in this part?
The box just disappeared. I don't know when I did that.
Okay, no, it's not. There's nothing wrong with you. The problem is that Robot Studio is acting like a real environment. So, for example, if you grab this box and put it somewhere else, it's not going to find it again. So you should go to the simulation and reset the whole thing. So you go here, simulation panel, go to reset, start from home. Which means this is start from home is the position that I saved in this file. So basically it's going to return this box to its original position, put the robot in this position. Now you can run your code again. Okay, so if I run my code again, you will see that it goes down, tries to grab the object, and then comes back and does the job for you.
Okay. Also, my pick and save point, the pick save and place save, I think I synchronized them into the station, but they appear like at the origin.
Yes.
And they,
okay. Yeah, I see what's happening there. Okay, that's actually a good question that I also saw last night when I was preparing this file. So when we do this, when we say variable robot target pick save, Robot Studio, I think by default, when you don't initiate the value, it automatically set it equal to 000 1101 000 So basically, when you make a target like this, where row target test target, Robot Studio automatically assumes that this target is at the center of coordination system. Okay, and that's why when you synchronize those targets to Robot Studio Station, it automatically puts them at the center of coordination system, and then you will get this error that says, I cannot reach that target because it's basically underneath the robot.
yeah.
So if you just simply sync it, it's going to put that target here, and any person who is familiar with basics of physics knows that this robot cannot reach out to that target because, first of all, it's underneath the robot. Second, the configuration of the robot cannot let it do that. So that's not a big deal. Just go back to your targets and just delete them from here because that's not a source of concern. Any other question? Good. So what we are going to do at this moment is basically some cleaning and organizing of our code. Okay, so for those of you who are familiar with any other programming language, basically what I'm going to do is to convert this big chunk of code into different procedures or functions or method or whatever we have it on other languages, and keep them in a kind of like tidy situation. Think about it this way. Instead of having all these lines of codes in one place, I'm going to break it down into some meaningful chunks and put them in different organizers. Like imagine that you have a couple of drawers and you have a bunch of pieces of papers and you want to organize them in the related categories in different drawers. So I can have a look here and say, okay, this part of my code is basically a kind of like housekeeping thing. I just basically ask the robot to go to the beginning point and make sure that the fingers are open. So that part of my code can be actually one chunk. So I'm going to mark this chunk as the first one. And then the second chunk of this code is the pick procedure. So basically at this part of my code, I just do the pickup. Okay, so I can keep these things as one chunk also. So let's do that one. And then the last part of my code is the placing part that I can keep as another chunk. So as you can see, I have 1, 2, 3 chunks plus some tasks that I can actually keep here. So in Robot Studio, in order to organize these things, we are using procedures. So you have seen procedures. Main is a procedure here. Those path 10, path 20 that we used to make are also procedures. And we can actually organize our code in procedures. So let's do that. I'm going to make a procedure. And to make a procedure, you just type PRO or whatever, like beginning of this procedure, and double hit tab. And then it populates this structure of code for you. It starts with the keyword pros. It has an ID, which is the name of this procedure, open parentheses and closing parentheses, which is something that we use for arguments, not for today. And then a bunch of statements, and then the end of procedure. So I'm going to grab this piece of code and Control X and paste it here. What happened to my code? Did I do something stupid with my code? Cut and paste. Yes, I think I hit something extra. So this piece of code, I'm going to call it housekeeping because it is some sort of housekeeping. So I do the housekeeping at the beginning of my code. So I move the robot to the beginning, to the starting point, and I make sure that the gripper is open. So I'm keeping this part here. If I hit apply, you will see that this housekeeping is showing up here. And the order of procedures are based on alphabet. So it doesn't matter if you have your housekeeping at the end of your code, it is going to show up in this corner in the alphabetic order. So the next piece of code that I want to organize is this part, which is the part that's doing the pickup process. So I'm going to make another procedure, and I will call this one pickup. And I can grab this piece of code from here and put them here. Okay, seems cool. And if I hit apply, you'll see that it shows up here as pickup. And the last one I want to do is to have this placing procedure. So pickup. And I call this place, and I grab this piece of code from here and done. Now, if I hit apply all, we have main, we have housekeeping, we have pickup, and we have place. So these are the things that I don't need to do, clean up everything on this side. So we have a really clean code that somehow does the job for us. Good, good, good for us. It seems like a plan. It seems clean. It seems that this part is very well organized. So let's run this code and see what will happen. So first, I'm going to go to simulator, reset everything to make sure that this box is here, my robot is in correct place. And then I will run my code. The moment of truth, what happened? Nothing is working. Nothing is happening. And you may get confused. What happened to my code? It's still there. It's not working. What's wrong? The answer is the fact that whenever we run a code in Rapid, Rapid doesn't bother itself with any of the procedures that you have except main. It just jumps over all your code, find where this line is located, it looks for main, and then runs everything inside main. And you can see inside main, we only have 4 lines of code, which only defines the pick safe and place safe. Nothing else. There's nothing about these move L, move J, pickup, place, and housekeeping. We need to call these procedures one by one in a specific order to make the robot run them. For example, I can say, please run housekeeping at this moment, and I put a semicolon at the end of the line. So whenever the code arrives at this line 26, it's not going to run line 27. It's going to jump here wherever this housekeeping is located, and it runs whatever inside that piece of code. And we know that after pick, we should go for place. And no, actually, we should go for pickup. My bad. And then we should go for place. Right now, this piece of code is what we are looking for. I can actually go one step further and define one other procedure. And let's call this one find safes. And let's put all these things inside this find safes. And first, let's call this find safes. Okay, now our code is way more elegant. We know exactly what's the process that we are going to work on. We exactly know what is happening inside each of those actions, and everything seems clear and nice and tidy. We can actually hit these small signs next to each of them to get a very clean view of everything. And we can see everything is located on the left side. So whenever we want to see and check, we can just basically go there, double click on them, and see what's happening inside of them. To be honest, with a code of like 67 lines, it's not going to make a huge difference. But if your code is like 2,000 lines of code, then having this option of capsulating each part of your code in one of these drawers is going to be significant help to understand what's happening. Now let's see what's happening. So this is the main procedure. As I mentioned, when you run your code is going to run main. And then it's going to one by one go through each of these procedures and run them and comes back. Do you remember I told something about procedural code? That's what's happening here. So let's go and do the job. So I'm going to ask this robot to do the job for us. So first it jumps to take care of the housekeeping, then it jumps to pickup, and then once it's done with the pickup, it's going to do the job with the place. So let's see, yeah, it's doing the job, doing the pickup, coming back there, doing the placing, and once it is done, it's going to finish everything in this line of code. Cool. We can actually call this housekeeping again at the end to make sure that it's coming back to the original place and opening the gripper. And that's actually a good idea because you want to make sure that whenever your code is done, the robot is getting back to its original position. So this is the Robot Studio Rapid Programming basics. You understood what is a piece of data, a value, what different types of data look like. For example, we get familiar with numbers, we got familiar with the tool data that we are usually not touching. We got familiar with rope targets, and we learned how to initiate one, how to declare and initiate one, actually declare and initiate, and how we can actually organize our code in different procedures, and how we can assign values, update values, and make motion commands. So for those of you who have background in programming, it seems like a piece of cake because this programming language is pretty simple and straightforward. For those of you who didn't have any background in programming, this may get a little bit complex and confusing. I strongly suggest you to read that handbook and try to write some of these codes and go on Slack, ask me questions. I'm going to respond. Ask your questions on the general channel so I can get back to you and everybody is going to see it. Despite the fact that Rapid is an easy, straightforward language, it has some special behavior that at the beginning you may not get exactly what's going on. But if you ask me, I'm going to quickly tell you. For example, if you miss one of these semicolons, it's going to show you angry error messages that you need to solve. Or sometimes, for example, if you try to define a variable somewhere here, it's going to throw another error that you might not get exactly what's happening. So whenever you face a problem like this, send me a screenshot and the text of screenshot of the whole thing with the error, like for example, like this. Send me a screenshot on Slack, and also send me the whole code on Slack as a file, so as a text file, so we can actually go through it and see what's happening. If I can solve the problem, it usually takes like more than around 2 or 3 minutes for me to solve this problem. But if you try to figure out by yourself, if it takes more than 10 minutes, don't waste your time anymore. Ask me quickly. Because for me, when I learned this language, it took me at one moment around 2 hours to just figure out what was the problem. And it was just simply one typo like this that I couldn't figure out what's wrong. Because sometimes Robot Studio doesn't show you exactly what's the problem. Okay, so read that handbook. Have a look at the slides. The handbook is already on the on Canvas. I think the slides are going to be there later today. And try to replicate the material in the handbook. For the next session, we are actually going to cover one of those assignments at the end of that handbook. That's it for today. If you have any question, I will be available for the next couple of minutes. Otherwise, have fun, enjoy your weekend, and enjoy learning Rapid.
I have a quick question. So when we synchronize, can we always synchronize to station? Can we always select the whole robot instead of picking where?
You can always select the whole thing. The problem is that Robot Studio is going to remember all the things that you have already synced and then add these things on top of them. So for example, you may have like 10 target ones or like 10 different pick points, which are just duplicated on top of each other. So make sure that you first do the cleanup. So let me just show you what's happening. If I do the same thing, happens, synchronize the station. And if I just click here, it's going to do everything. You see that? It does the job. And then if I do it again, it again copies everything on top of the previous ones. And sometimes it gets really, really nasty. So don't do that. like if you're doing it, just be careful about what you are copying, because like these are going to show up here, and then when you're running your code, they're not going to show up. This is not a big deal right now because we only have 3 targets, but when you are doing, for example, hardware coding with HAL, we may have like 2,000 targets, and every time you synchronize them, 2,000 targets are going to show up on your screen, which is not the best way to handle and treat your graphic cards.
Okay.
Yeah. Any other question? I know the topic was like really densely packed, but if you practice it, it's going to be a lot of fun. Okay, good. Take care of yourself, stay home, put on mask, wash your hands, and enjoy Robot Studio. Have a good one.